Hey everyone, we're going to look at number 1 and 2 from section 1.5 in Achieve. We're to evaluate without a calculator this expression. So what is that? Sine with a -1 exponent? Well, that actually is what we call the inverse sine function. And that -1 is actually not an exponent. It's indicating an inverse. So please note that this is not 1 divided by sine inverse. 1 divided by sine, by the way, is cosecant, right? That's not what we're talking about. In fact, the inverse sine of 1 is also written arc sine of 1. So arc sine, inverse sine, this is the inverse sine function. And the relationship is, of course, if theta is the inverse sine of 1, what we're looking for, the inverse relationship says, number 1, of course, that sine of theta is equal to 1. But also when we define this inverse function, if you remember from pre-calculus, we had to make a restriction on the domain of the sine function in order to make the sine function 1-to-1. And the interval that we choose typically, and the one that we're going to use, is from -pi/2 to pi/2. Just looking at the graph of the sine function will help you remember that, hopefully. This is a portion of the graph. It will continue down, going backwards here at -pi/2, it's -1, and then it's, continuing that up and down motion. It's clearly not 1-to-1, meaning that for each input, there is not a unique output. For instance, at 0, sine is 0, but also at pi, sine is 0, and at 2 pi, sine is 0, and so on. Every multiple of pi, the sine is equal to 0. Or at pi/2, it's 1, but also over here, if we add 4 pi, or 2 pi, 4 pi/2, I get 5 pi/2, it's also equal to 1. And so it's not 1-to-1. What we do is we restrict it just on the interval from -pi/2, where it's -1, up to pi/2, where it's +1. So just on this interval, okay, from here to here. So that's important because there are many values of theta where the sine of theta is equal to 1. As I said, it's equal to 1 at pi/2, it's equal to 1 at 5 pi/2, at 9 pi/2, and so on. Every multiple of 2 pi, there's infinitely many, but the one that we want is the one that's in between -pi/2 and pi/2. So we're talking about 0 to pi/2, and then we have to think about the negative value. So instead of 11 pi/6, this would be -pi/6. This would be -pi/4. This would be -pi/3. This would be -pi/2. That's the way we have to think about it. Okay, so where is the sine going to be equal to 1? Well, remember, the sine is the y coordinate, and where is it equal to 1? Well, right here at pi/2. And so the angle we're looking for is indeed pi/2. So sine inverse of 1 is pi/2. Now, what if I was looking for sine inverse? What if, just a little aside here, what if I was looking for sine inverse of -1? What would that be? Well, somebody might say, well, y is equal to -1 down here, so it's 3 pi/2. That would be incorrect. 3 pi/2 is not the inverse sine of -1, because the value of the angle has to be between -pi/2 and pi/2. 3 pi/2 is not in that interval. So in fact, the inverse sine of -1, remember, this is going down in the negative direction. This is -pi/6, -pi/4, -pi/3, -pi/2. So the inverse sine of -1 is actually -pi/2. Okay, so be careful about that. Now, number 2 is something similar. Evaluate without using a calculator. This is secant inverse of this weird looking expression, -2 squared root of 3/3. So again, I'm going to let theta be secant inverse of -2 squared root of 3/3. Thus, what do we know? Secant of theta must be equal to -2 squared root of 3/3. Again, this is the inverse secant function. So given this statement, this is the inverse relationship. Okay, but we also have theta this time between 0 and pi. Why is that? Well, if we look at the secant function, we choose the interval from 0 to pi because it's 1-to-1 there. We have all the values here. It's at 0, it's 1, and then it goes up to infinity as we get closer to pi/2. And here at pi, it's -1. And as we get closer to pi/2 from above, we go to -infinity. So the values of secant, the output, are always values greater than or equal to 1 less than or equal to -1, no values in between -1 and 1. But the secant function is closely related to the cosine function, right? They're reciprocals, right? The reciprocal of secant is cosine, the reciprocal of cosine is secant. So really, you can see when we define the inverse cosine function, we restrict it on the interval from 0 to pi. On this interval, it's 1 to 1 and takes on all its values. And so this is the restriction that works for cosine and secant to define the inverse functions for them. Sine and cosecant go together, and obviously tangent and cotangent go together in terms of that. So it is important to remember that. Now, when I'm doing, secant theta is equal to this, what I'm going to do is actually just go ahead and change it to a cosine problem, right? Secant theta is this value. Since cosine theta is the reciprocal, I'll just say, well, cosine theta is the reciprocal of this, which would be -3 divided by 2√3, right? Just flip that expression, reciprocal. And then I can rewrite this by rationalizing. Do you remember how to do that? Multiply top and bottom by square root of 3. Up top, I get -3 square root of 3. On the bottom, I get square root of 3 times square root of 3 is 3. 3 times 2 is 6. But then the 3/6 simplifies down to 1/2. And I get this. That looks familiar, I hope. So basically what we're saying is, we want to find where is cosine theta equal to -square root of 3 over 2, because that's where secant theta is equal to -2 square root of 3 over 3. And we want theta between 0 and pi. So if I go to my unit circle, remember the cosine is the x coordinate, where on the interval from 0 to pi is the x coordinate -square root of 3 over 2. Answer 5 pi over 6. Right. And so our angle we're looking for is 5 pi over 6. Therefore, the inverse secant of -2 square root of 3 over 3 is 5 pi over 6. Okay, so finding these inverse functions important. Again, we do a lot of this when we're solving equations as well, involving trig functions. So you need to be real familiar again with this unit circle. Again, this unit circle is on this trigonometry and algebra help sheet. You will have this on the test. Again, you can find a copy of this in the resource module rather in Brightspace. I'll provide a copy of it on the test, but I would have that handy, printed out, or have it open so that you can look at it and refer to it as you're doing the homework. Okay, I hope this helps.